saying that, so he's saying write an ionic equation to show the spontaneous reaction that occurs when an electric current is drawn from the cell. I mean, so what is the spontaneous reaction? So it was two electrodes, right? It was the first one. The equations are given, right? So it's Au and Au ions, and the other one was nitric acid and NO gas. So I think it's the third one, right? So the higher one gains electrons, the lower one loses electrons, and that's it. So it's going to be what, Au3 plus, NO gas, and two water molecules, and the product is what? Product is Au solid, and what else is formed? In the third equation, it's NO3 minus 1 that's getting formed, and 4H plus 1. So that's it. Okay, the electrons are already balanced, so I didn't do anything. I didn't multiply the equations. And you have to calculate the E naught cell, so that's easy as well. That's reduction minus oxidation. So 1.5 minus what, 0.96. So that gives you 0.54. ठीक है, clear है?
Yep, it's clear.
So now so I'm going to rub this off. Now the next part, ठीक है, the one that's written at the bottom, is saying that gold can be oxidized by a mixture of hydrochloric acid and concentrated nitric acid. So and he says that is known as aqua regia, and the concentration of hydrochloric acid is 12 mole per dm cube, and of nitric acid that's 16 mole per dm cube. So he's saying explain why aqua regia is able to dissolve gold. So you've got to justify that. He's saying that gold dissolves when you have a mixture of HCl and HNO3, and these two happen to be very concentrated. So why does gold dissolve when and they were very specific about the equations that you were going to discuss. So he's saying in your answer statement, explain what effect the use of concentrated hydrochloric acid and nitric acid have on E values of equations 2 and 3. So you're basically focusing on equation number 2 and 3. So 3 has nitric acid. The first one has I mean it's got a hydrochloric acid it's got Cl ions, so probably hydrochloric acid is providing the Cl ions. So we're looking at equations number 2 and 3. Now, if I look at equations 2 and 3, gold in the presence of concentrated nitric acid, then the reaction is not feasible because gold is not going to dissolve. And nitric acid is not going to get reduced. Why? Because electrons lose कौन करता है? The one that's got the lower potential, and gains the one that's got the higher potential, which is not true over here. You're going to get a negative E naught cell. Like if you do reduction minus oxidation, you're going to get minus 0.04 volts. So that's a reaction that's not feasible. ठीक है, Vardha, is this part clear?
Yep, it's clear.
So now explain to me, why does gold dissolve? What happens to if you use concentrated hydrochloric acid? What would happen to this equilibrium? Where would it shift if I use concentrated Cl ions?
Will it shift to the left?
Okay, so this equilibrium will produce more electrons, right? If you get more electrons, what will happen to the electrode potential? Because more electrons are getting produced. हमने क्या पढ़ा था? What happens when the electrode starts producing more electrons?
It decreases.
So let's hypothetically say that it decreases and it becomes 0.80 volts, right? And if you use concentrated nitric acid, where would the equilibrium shift? This is HNO3 basically. H plus 1 and NO3 minus 1. So this will shift forward, right? And Okay, and when it shifts forward, it increases, right? So let's say its new value is 1.20 volts. Now your E naught cell is going to be positive because reduction minus oxidation is going to give you a positive E naught cell. This will be the higher voltage, higher potential, so it will gain electrons. This will be the lower potential, so it will lose electrons. So now gold will dissolve. So that's what you're going to write. You're going to write that this equilibrium shifts to the left, so it becomes lower. And this equilibrium shifts to the right, equilibrium number 3. So it becomes higher, and that's why your E naught cell, and not, I mean, you don't have to write not because it's non-standard conditions. So your E cell is now a positive value. So that means the reaction is feasible. Is that clear?
Yep, it's clear.
I said, you've got the data booklet. Calculate the E cell for this reaction. I mean, the overall equation is given. By just looking at the overall equation, which 2 electrodes do you think are involved in this reaction?
Is it copper electrodes?
No, but which one? I mean, there's a specific electrode, right? This is copper 2 plus and copper plus 1. So it's the copper 2 plus copper plus 1 electrode, right? Can you tell me what the value is for this?
Um, 0.15.
And according to the equation, it's moving in the forward direction, right? And what's the other electrode?
I2 / I minus.
TGS, so it's this one. It's 2i minus 1, and that's what's the value?
0.54.
TK. And this electrode, I minus 1 to I2, right? So that means in the reaction, it's going in the backward direction. So do you think it's a feasible reaction or not?
It's not, because it's less than 0.
I think it's going to be less than 0 because the one that's going to gain electrons, it's supposed to have a higher potential, which is not true over here. I mean, this potential is actually lower than this. So this reaction will not happen. So if you do reduction minus oxidation, you're going to get a negative value, which is what I think it's going to be. Okay, it's 0.15 minus 0.54. So that's what?
0.39.
You got 0.39. So explain how the value of E naught cell calculator predicts the reaction. It's a negative. That's what predicts. The reaction is not going to happen.